Hello folks, this is Kevin again, and today I'm going to show an implementation of a machine learning algorithm to identify traffic signs. So right now I'm just going to run the code. So Python traffic.py and then gtsrb, and then that should start the program. So I'm first going to show you basically what's involved. So gtsrb, I've gone to the file here. Here are all of the 43 data sets. And if we go into 0 here, I'm going to open this ppm file. And it's going to show you, I don't know if you can see this, if it's too small, a traffic sign with 20 on it, probably 20 kilometers an hour. These are German traffic signs. So yeah, and then that's everything in the 0 data set. And then there's the 1 data set too, with each with different signs, probably some stop signs or pedestrian signs mixed in there. And so basically this machine learning algorithm, what I've done here is you can see the output here for each of the different layers. So first we have a convolution matrix, a convolution sequence. And so these images, I've resized them each to 30 by 30. And then this convolution layer, basically it applies 32 different filters and it actually shrinks the image, as you can see, to 28 by 28, shrinks it slightly. So the convolution step applies just 32 different filters to see basically which one's the best here. Oh, and I actually stopped the algorithm running here. We'll start again. And then after that, we have the max pooling step. So what the max pooling step does is in each 2 by 2 array, it takes the maximum value. And then we have another convolution matrix. And by the way, the max pooling step shrinks the image expectedly down to a size of 14 by 14 because it takes a 2 by 2 array and takes the maximum value. Then we have another convolution step and then another max pooling step. And finally, after all of these convolution layers are done, we flatten everything so that instead of being a 6 by 6 sort of a pixel array with 64 outputs representing the 64 filters, we flattened it all into 1 dimensions. So 2304, this is 6 times 6 times 64. And then we finally have basically our neural network. So we have one hidden layer with 256 different nodes. I tested basically 128 nodes, powers of 2, going from 2 all the way up to 512 and 1024. And then 256 was actually pretty optimal, both speed-wise to decrease the amount of time that all of these steps take, the training steps take, and for accuracy. And then finally, after that, we have a dropout factor. So on each iteration of each of these training steps, these epochs, we drop out half of the nodes, basically to make our network more resilient so they don't rely on any one of the nodes too much. And then finally, we have our 43 outputs to classify whether for our test variables, test images, whether each of them is a stop sign, etc., or a speed sign. And then so finally, what we have see here is I've achieved an accuracy based on, so we have 10 epochs here, and then as you can see, the accuracy is improving based on each of the training, each run of the training. And then in our final sample, we achieve an accuracy of 0.9885 and a loss of 0.0430. Probably improve the accuracy by running more epochs or maybe by tweaking my algorithm, although I did a fair bit of tweaking with this. But yeah, that's pretty reasonable, 0.98% accurate. Usually I get around the high 0.98% or the low 99% for an accuracy and a loss of around 0.04, 0.05. So this is right in line with what I've been getting just with this model right here. So then again, thank you. This is Traffic again, in a machine learning algorithm to predict and classify traffic signs. And I hope to see you again soon.